Hello there. I was once lucky enough to get the opportunity to visit an amazing place, a place called CERN in Switzerland. But first, I've got to get there.
Fasten your seatbelts. For passengers just joining us, we do ask you to keep making your way towards the rear of the cabin. When
So now I'm here, I'll tell you a little bit about the place. CERN is the European Organisation for Nuclear Research. It is nestled just under the Alps, straddling the border between Switzerland and France. It was set up around 1954 by a group of physicists who wanted physics to have a positive way forward after the horrors of the Second World War. The way they carry this research out is by using things called particle accelerators that are found deep underground. And what they do is they find the things that make matter, that make everything. You, me, everything. I was lucky enough to visit one of the detectors that see these particles. It's called CMS. And here is a video showing my trip down to the detector. Well, I say to the detector, we weren't actually allowed in because it wasn't safe. The proton beams that feed these detectors come from one of the particle accelerators. This is called the Large Hadron Collider, or LHC. It is 27 kilometers round. Inside this tunnel you find these blue pipes. This is where the protons zoom round at 99.99999% the speed of light. This is what the inside of one of the tubes looks like, and it is cooled down to a temperature of minus 271 degrees Celsius. That's colder than space. As these two proton beams collide into each other, they recreate conditions in a tiny point of space similar to that just a fraction of a second after the Big Bang. One of the main goals of the LHC is to look into this thing called the Standard Model. This is looking at tiny particles called quarks, leptons and bosons. As we left the lift after dropping just over 90 metres, we saw this sign. This is a no pacemaker sign. Now the reason for that is because the LHC uses huge magnetic fields to bend and focus the protons. To do that, you need huge amounts of electricity. Now that small strip of metal is a metal called niobium titanium and can carry exactly the same current as that huge piece of copper because it's called a superconductor. Here you can see them arranged in 4 groups around these beam tubes. This is called a quadrupole electromagnet and is used to focus the proton beams. In the LHC, they have a lot of safety and security checks. As I was at the front of the queue as we were walking round, I was lucky enough to get checked out to see if I was radioactive.
this, you can check if you are radioactive.
I'm not.
No, you are.
Get in.
This is,
The reason they do this is because inside the tunnel, when the beam's running, like now, there is radiation produced. We then reach the final part of security. Beyond this door, you enter the tunnel itself and the detector chambers. Now the final security measure is something pretty cool. If you actually look here, that on the wall is a retina scanner. Through this door is one of the detectors. It's called the Compact Muon Solenoid, or CMS. This does the job of looking for those particles. These machines are awesome. They are massive. This one is 4 stories high. The way the detectors work is they utilise Einstein's E equals mc squared. The protons fly in with such high energy and collide that new matter is formed, and it is this matter that are detected in these sorts of pictures. The scientists can then decipher this and find out what particles were made. In order to do this, they need some serious computing power. There were racks of computers like this everywhere. The detectors are controlled from places like this. There are 3 other detectors in the LHC. There's this one, Atlas, another broad spectrum detector like CMS. This one is even bigger. This is 7 stories high. There is Alice, which looks at the collisions of lead ions, very high energy collisions. And there is the LHCb. Now I get asked a lot of times by people when I say about my trip to CERN, why? Why are the scientists and physicists going to all this effort? What's the point? Well, I was lucky enough to ask some of these questions to one of the physicists at CERN.
Okay, hi. So who are you then?
My name is Rolf Landauer. I'm a research physicist at CERN.
Yeah.
I've done a lot of research on antimatter, and I'm now head of education and public outreach.
Quality. What's your favourite fact about CERN?
Well, there are many favorite facts. I mean, it's first of all, we are looking into very fundamental questions, how the universe came about. But it's also a very nice place because we have 100 nationalities of people working together. It's very exciting.
Brilliant. Could you sum CERN up in one word?
Fundamental.
And I completely agree. It's fundamental for 2 reasons. One, the research at CERN and by physicists say about knowing the atom and the electron led to having modern electronics. No physics, no mobile phones. The World Wide Web was invented at CERN, without which you would not be able to be watching this video now. But more than just these material reasons, there's the bigger reason. Humans have always strived to find their place in the universe, to ask those questions, to find out our origins, where we've come from and where we're going. And without physics, I don't think we'll know. So never stop asking. Goodbye.